Okay, so let's look at this question. So we are saying that copy and complete the table of values where P and Q are constants for the relation y is equal to px squared plus 2x plus q. So this is the table given where we have the x values and the y values, but we have omitted some of the values for y. In this case, we need to find all those values. Okay, so if you look at the B, we are saying that we are to use what the table to find the values of P and Q. Okay, so it means that whatever values we are going to get from the relation, okay, for P and Q, we need to use the table. Okay, but how do we use the table? So we are going to look at how. And also in the C, we are asked to use a scale of 2 centimeters to 1 unit on the axis, and then we draw the graph of the relation given the interval, okay, which is -2 up to 4. Okay, and after that, we also use the graph to find or obtain the roots of the relation and also the line of symmetry. Okay, yes, so this is one of the aspects of the senior high school mathematics. Okay, yes, you can get this in both the elective maths and the core maths, but apparently if you look at this question you can see that this is for the core maths mathematics question. So we'll not waste my time. Let's quickly look at how best we can solve this question. Okay, so looking at this one, the question is saying that we should complete copy and complete the table. It says so we need to complete the table, but you realize that the relation given, we are given what it is given as what a quadratic function. Okay, yes, this is a quadratic function, but we have what P and Q. We don't know those values. Before we be able to find those values, we have to look at for the values of P and Q. Then we substitute it back before we can find that. Okay, yes. So let's look at how we can find the values of P. Okay, yeah. So what we do is to find the values of P and Q, we can choose two different values from each of the y and x. Okay, so we can either choose -2 for x and -4, and also choose -1 for x and 1 for what y. Then we substitute. At the end of the day, we are going to get two different equations. That is what simultaneous equation. Then we solve them and find the values of a. But in our case, I will prefer using -1 for x and 1 for y, and then 0 for x and 4 for y. That will be easy. So whenever you are solving this question, I will advise that you choose values that will make the work easier for you, and also ensure that whenever you are choosing values from the table, you choose values that you can get it corresponding. So if you choose a value from the x-axis, you may have to make sure that that value you are choosing from the table, it has it corresponding. Because if you look at the one in the x-axis, we don't have it corresponding y values. If you look at the two, the same thing. So we can choose them, but we choose those that they have corresponding values. So in this case, I would rather choose the -1 and 1, and also I will choose what the 0 and the 4 as my coordinate, and then do the substitution. Okay, so I will deal with the first one. It means that when x is -1, y is what 1. Then I will just do substitution. Okay, so you just do substitution and then you get this. So at the end of the day, you are going to get what P plus Q is equal to 3. We can call this equation 1. Yes, you can call this equation 1. Then we use the 0 and the 4 as well. We do the substitution. Okay, yes, and then after doing that, you realize that because it involves 0, that's why I say you choose numbers or values that will be easy for you. So we have Q as 4. Once we have Q as 4, we can just substitute or put Q into equation 1 and then solve for what P. All right, so if we substitute the values, then we are going to get P is equal to 3 minus 4, which will give us -1. This suggests that P is equal to 1, Q is equal to 4. So even the B part is answered. Okay, yes, so That is it. Okay. Yes. So that is what we have. Now, once we have P and Q, then we can just substitute into the relation and get the actual quadratic what function. Okay, or we get the actual relation. Okay, so we just substitute -1 for P and 4 for Q. Okay, and that's going to give us the equation which is given by y is equal to x squared minus plus 2x plus 4. That is our equation. And once we are able to get our equation, then completing the table becomes easy for us. So we just have to just go in, and then so let's take our table again. Good. So here we are only going to work with those that we don't have their corresponding what y value. So if we take the first one, which is 1, we just substitute it to the equation there, then we get the values for y, and that gives us what, 5. Okay, then we do with 2 as well. We substitute 2 into the equation, and then we are going to get what, y to be 4. We do the same for 3. Okay, we do the substitution and we get y to be what, 1, and the same applies to 4. So it means that when x is 4, y is what, -4. So once we are able to work out like this, then we just what, we can just put the numbers there, we fill the table, and that answers the first one because we are asked to complete the table. Okay, and that is very perfect. The B asks us to find the values of P and Q, and we've already calculated that. So we got Q to be 4 and P to be what, -1. That is the P. Now let's look at the C. So for the C, we are asked to use a scale of 2 centimeters to 1 unit on the axis, that is both the y and the x-axis. We have to draw the graph of the relation. Okay, so it means that we are going to draw the quadratic expression there, okay, or the quadratic equation there. We are going to draw the graph. Okay, so we need to get our graph. Okay, so we take this as our graph. Now they said the scale given was 2 centimeters to 1 unit. So when we talk of 2 centimeters to 1 unit, in this case it means that every box, every interval will be what, 2 centimeters. So if we divide every box into 2 equal parts, then it means half will be what, 1 centimeters. So that is how it is going to be done. And the 1 unit also means that each value should be increased by what, 1. So it means if I start from 0, my next centimeter will be what, 1. My next centimeter will be 2, 3, 4. It means that, so if we say 1 unit, it means that it should be what, counting numbers from 1, okay, 2, 3, 4, okay, yes, or whole numbers, because the center starts with what, the origin, that is 0. Okay, that is the meaning of the 2 centimeters to 1 unit. I repeat again, I said the 2 centimeters, it means that if you take every box, each interval, okay, is what we are using as 2 centimeters. Okay, yes, and the 1 unit means you should take what, a whole number or natural number, start from 1, 2, 3 up going. The interval should be 1, 1. We add 1, it should be increased by what, 1. Yes, so let's draw two lines. That's the vertical, which is the y-axis, okay, and then the horizontal line, which is also the x-axis. Okay, yes, so once we have this, then we can write our scale. That is, so this is what, the 2 centimeters to 1 unit. Okay, so the numbers, you could see that it starts from 0, 1, 2, 3 to my right on the x-axis, and -1, -2, up to -5 to my left on the x-axis, and the same applies on the y-axis. Okay, yes, so once you have this, then the rest becomes what, easy for you. Okay, yes. Yes, so once we have this, then we can just plot in what, the points. Okay, so let's bring our table once again. Okay, so we are going to take the first one, which is -2 and -4. So it means when x is -2, y is what, -4. So we trace it Okay, we trace it from 2, and then where 4 is, we trace it again, and where they intersect, we make what? Asterisk there. Okay, yes, so that is our point of intersection. Okay, yes, then we move on to the next one, which is x is -1, y is 1. Okay, and then we do same. So we'll be doing that, repeat it like that. Okay, yes, so that is what we are doing. Okay, then we move on to the next one. We pick 0 and 4. Okay, then that one the same. So how we do the first one, it follows like that. Okay, yes, we will be making asterisk for their point of intersection. Okay, yes, we do the same so that we get our points. Okay, yes, so we pick 1 and 5 and they intersect at that point. Then we pick what? Our 2 and 4 as well. Okay, yes, and that one also, they will intersect at that point. We make asterisk there. All right, so we do it until we are done with all the values in the table. Okay, yes, so that is how it is done. Very simple, very easy. Okay, yes, we need all these points so that we get our curve very nice. Okay, yes, so once you get the correct points, you see that your curve becomes very nice. That's it. Okay, yes, exactly. So now that we have all the points, then you just use your sharpened out pencil to join all the points to form what? A nice curve. Okay, so we join them and then you see that this is our curve. Very nice, right? Good. So once we get this, then you know that in this form, you see that it is in the N shape. Okay, N shape. So we can say that this is what? A maximum curve. Okay, when it has N shape like this, that means you have what? A maximum curve. All right, yes. If it is U shape, then you have what? Minimum curve. So take note of that. Great. So once we have this one, then we need to find the other one. Now if you look at the D says we should find the roots. So how do we find the root of a quadratic equation or quadratic curve like this? Now you get the root of the equation where you realize that the curve what intersects on the x-axis. So you realize that the curve intersect at my left side, it intersects here. What value is there? You realize that we have -1. If you move to my left, you are reaching what? -2. So that where the line intersect exactly, that's the value. Okay, you could see that, or we can conclude that it's either you get a -1.2 or -1.3 or maybe -1.24 or something like that. Yes, so we can choose -1.2 as our answer. So that is one of the roots. Then we look at our right side where the curve intersects the x-axis again. So you realize that at this point as well. Good, and that one too, we can see that is 3.2. So these two values becomes what? The roots of the relation or the quadratic equation. So whenever you are asked to find the root, this is using the graph. This is what you mean. There are times that you may not be required to use the graph, but you can be asked to find the root of the quadratic equation. That one you solve it the normal way we solve quadratic equation. You solve it like that. You equate to 0 and solve for x. Okay, yes, but in the case of using the graph to solve for x, that is the same as finding the root, or we can also say find the truth set or find the solution set. Okay, yes, exactly. So that is answers what? So it means that the root of the relations are x is equal to negative 1.2 and x is equal to negative 3.2. Yes. Yes, so that's it. Okay, now let's look at the last question. The last question, we are asked to find the equation of line of what? Symmetry. So what at all is the line of symmetry? So when we talk of the line of symmetry, we are talking about what? A vertical line that what intersects the vertex of the curve, okay, the point where the curve turns at the turning point, okay, the vertex of the curve. That is, if you draw a vertical line and the vertical line what intersects exactly that turning point or that vertex, then that line is what we call what the line of symmetry. In other way, you can also say the line of symmetry divides the curve into two equal parts. Okay, yes, so it means that if it divides, you can have what a reflection of the other. Okay, if you try to flip or fold the one part to the other, it will cover exactly. So once that line divides into two equal parts, then we call that line also what line of symmetry. Okay, so in this case, how do you find the equation of axis of symmetry or line of symmetry? So to find that value, it's just, or the equation, just a matter of what looking at the value on the x-axis where that line of symmetry what intersects on the x-axis. Okay, so you identify the vertex of the curve. Okay, you identify the vertex of the curve. And then you trace a line from that vertex to intersect the x-axis, okay, like this. Okay, yes, so you see that this is the line. Okay, you realize that the line intersects the vertex, okay, the turning point, okay, of the curve. That line, then you trace it to where it cuts the x-axis or where it intersects the x-axis. That value there becomes what the equation of axis of symmetry. So take note of that. Whenever we ask you to find the equation of axis of symmetry, you just have to what identify the vertex of the curve, then draw a line from that point to intersect what the line for the x-axis. Then you identify the value there. That value becomes what the equation of axis of symmetry. Okay, yes, there is also a formula you can use. Okay, so you can also use negative b over 2a. That is also a formula we use to find the equation of axis of symmetry. So you can use that one, okay, that formula also to test whether your answer is right. So in this case, what will be your conclusion? You realize that the line of symmetry what passes through where 1 on the x-axis, and that becomes our equation of axis of symmetry. Okay, very easy, right? Yes, so if that's the case, then we can conclude that the equation of the line of symmetry is what given us what x is equal to 1. As I said you can also use the formula negative b divided by 2a. You can also use it to find the equation of axis of symmetry. Yeah, so that is all. Okay, so you realize that that answers the question. Okay, it's very easy, right? So when you get such questions, these are the processes that you go through. Okay, yeah, so if that's the case, then let's end here and continue next time. My name is Evans. This is Masways TV. I'm still your mathematics facilitator. Kindly follow me on YouTube, subscribe to my YouTube channel, like and share the videos. So I will be there to solve more questions. I will bring you more questions, more solutions, and interesting topics as long as mathematics is concerned. So see you next time. Bye bye.